Hi class, today we're going to go a little further in our study of energy and work and transfer of energy and look at the definition of work. Work is the transfer of energy, so we just talked about potential and kinetic energy and how if you have a ball at the top of a ramp, it has potential energy, and once it starts moving, that would be kinetic energy. And work is going to be the transfer of that energy from something like potential to kinetic or chemical to mechanical, caused by a force that makes the object move. So in order to do work, you have to have motion of the object. And you'll see that in the equation when we do that on the next slide. So an example, if you try to lift the front of a car, you will apply a large force, but if the car does not move, you have done no work on the car. Now, you have done work on your muscles have contracted, they've moved, but if we're looking at the car, we've done no work on the car if the car has not moved. So our equation is work is equal to force times distance. It is measured in joules. When you finish the answer, you need to put joules afterwards. Our example here, a father lifts his daughter repeatedly into the air. How much work does he do with each lift? Assuming he lifts her 2 meters and exerts an average force of 190 newtons. So our force is 190, distance is 2. We're going to multiply those together and put it into our work equation, and the answer will be 380 joules of work. Energy and work, when we look at those and put them together, whenever work is done, energy is transferred to another system. So energy is just that ability to do work. Our unit for energy is the joule, unit for work is the joule. So here's some examples kind of how that would work. If you take the example set up here, we have light that is turned into chemical energy through the process of photosynthesis. Here we have electrical energy turned into thermal energy to heat the substances that are inside of that container. We have chemical energy of just a food product being used by the person as mechanical energy. And then we have chemical energy of the fuel being used as mechanical energy in the car. And you can see some examples over here as well. Chemical energy converted to electrical, converted to kinetic, or chemical energy can go straight to kinetic. And so you can see kind of that comparison of what's happening from one system to another. That energy is transferred. Some of the energy we've talked about before, it doesn't get lost, but it might move out of the system as heat or some other form due to friction or air resistance, something like that. Here's our final example just to show you a process through a straight line path. We did do a lab with this as well, a virtual lab, so you can refer back to that as you need to as well.